So, what was the question? The question gave you this log equation and they asked you to solve it. Solve for the value or values of x. Log, log, bruh.
I have exam. I have advanced exam Monday.
Good luck. You do fine though, for sure.
Yeah.
You studied? Good. You studied for your exam? Yeah, no.
Study what?
Did you,
Diagram?
did you study for your exam?
Oh, but look to it. I'm going to study tomorrow because today I have a lot of homework to do. Remember, this week is the report week. I did my missing work.
Oh, okay.
Yeah, I'm gonna study tomorrow.
Well, what would we do here? We know there are two rules that we consider when solving log equations. The first one, if I'm given log form, then I can write it in exponential form. The second one, if I have log on two sides and they're both to the same base, then I could say if log of n to the base a is equal to log of m to the base a, then I would say n is equal to m. So what exactly do we do here? Well, looking at this equation, this is not in log form and it's not in the other form, right? So we need to find a way to write it in one of those forms because that's the only way I'll be able to solve this. So what can I do? Well, I can carry across this, bring it over here to get, there's just one way of solving it, right? This minus, will become plus 7x plus 1, and this plus 1, and this would give me 1. We know a rule that says log of n to the base a plus log m to the base a is log of nm, so n times m to the base a. So what does that mean? According to my law, log of 2x minus 3 to the base 7 plus log of x plus 1 to the base 7 is supposed to give me log of 2x minus 3 times x plus 1 to the base 7, and this is equal to 1. Following so far?
Yeah, following.
Okay, sure, follow now. Yeah. Well, yeah. Anyways, now I can say this is log form. Remember? Okay, let me just erase this. Erase. Erasing the blue part as well. Remember, log form is log of x to the base a is equal to n. In this case, okay, let me just write it down. Erasing this. So I can tell that this is in log form. What is log form? Well, remember that log form looks like this. So log of x to the base a is equal to n. This is in log form. A would be 7, x is represented by this, and then n is 1. And we said if we're given log form, that we can write the log form into exponential form, right? And exponential form looks like this. A to the power of n is equal to x. So what does that mean? I can rewrite this, which is in log form, into exponential form. How would I do that? Well, let me just erase a pane. I'll leave that right there. So writing that blue equation, oh my gosh, am I colorblind now? This yellow equation into exponential form. A, which is the base, 7, n is 1, that's a 1, is equal to x, which in this case is this. Kinda. I need to be sure. So which part did I lose? Which part you didn't understand?
It's alright. It's okay.
Let me know if I lose you, right? So now I can just solve for x using algebra, right? Let's erase. I would expand these brackets. When I expand those brackets, I could tell that I would get a quadratic. So I know I have to solve a quadratic. Let me go back to yellow. So anything raised to the power of 1, we learned this when we're doing exponentials in itself, right? So 7 raised to the power of 1 is 7. So I'll just go back to 7. If I expand these brackets, I will get 2x squared plus 2x minus 3x minus 3. So like I said, I know I'm going to get a quadratic, right? If I simplify further, I would get I can write this as 2x squared minus x minus 10. How did I get minus 10? I brought the 7 over, right? So minus 3 minus 7 is minus 10. Now that I have a quadratic, I can solve it to find my values of x. So this right here, this can't factorize. Hold on. That particular quadratic can't factorize. So what would you do? Well, you would move on to the formula. Since it can't factorize, right? Remember, not all quadratics can factorize. So if I use the formula, let me just clear this off. If I use the formula, minus b plus or minus the square root of b squared minus 4ac all on 2a. If you look at the quadratic we had before, b was minus 1. So that's minus minus 1, which is 1, plus or minus the square root of b squared minus 1 squared is 1. That's minus 4 times a. It was 2. So that's 8. And then c was 10. It was 2x, what's the quadratic? 2x squared minus x minus 10. X is 2, c, okay. It was 2, right? So 2 times 2 is 4. 1 plus or minus the square root of 81 divided by 4. So what does that mean? That means that x, the values of x, let me just erase this. So we know this already, right? So we know the formula, we know to substitute the values, but I'm still doing it.
Wait, Doris the pooper. Oh yeah.
That was just the quadratic formula.
Oh.
You need me to rewrite it?
No, it's okay. Oh, it's okay.
So using the formula, I just found out that the values of x would be x is equal to 1 plus the square root of 81 is 9, right? So I'll just put 9 divided by 4. Or 1 minus 9 divided by 4. If I simplify this, 1 plus 9, that's 10. 10 on 4 would reduce to 5 on 2. 1 minus 9, that's minus 8. And minus 8 divided by 4 would give me minus 2. So they asked me to solve. I would say, okay, my values are x is 5 on 2 and x is minus 2. But this is logs. You see, when you're dealing with logs and you have a negative number, be very careful. You need to make sure that negative number doesn't affect anything. What was the original question? Well, the original question was log of 2x minus 3 to the base 7 is equal to 1 minus log of x plus 1 to the base 7. If I substitute this value of x into here, I would be fine, right? Because 5 on 2 times 2, that'll give me 5. 5 minus 3 is 2, so that's okay. And then 5 on 2 plus 1, that's fine as well, right? It'll give me 7 on 2, so that's okay. But if I substitute this value here, the minus 2, 2 times minus 2, that's minus 4. Minus 4 minus 3, that's minus 7. But we know we cannot find log of a negative number. This number cannot be negative, and we said that this number cannot be negative. That's why this value for x is equal to minus 2, that value is invalid. Invalid. So say this was a exam question, right? You have to do all of this and you have to state invalid, right? You can't just say, oh, I know minus 2 is invalid, let me just put 5 on 2. You actually have to write so that they know that you understand that minus 2 is invalid. Why is minus 2 invalid? If I substitute it into here, this number would be negative. We know we cannot find log of a negative number. That's why this value is invalid. Same thing here. If I substitute minus 2, I'll get minus 2 plus 1, which is minus 1. Minus 1 is a negative number. I cannot find log of a negative number. That's why x minus 2 is invalid. And the answer for this question here was
X minus 2x equal 5 over 2.
But minus 2 is invalid.
Minus 2 is invalid, yeah.
You have to put this part, right? Okay, yeah, that's why this right here was the answer. Any questions on that?
I'm okay.
Okay. The people who weren't here and who didn't do the quiz, well, I'll post it so you can do it after. Let me just go through it real quickly. So the people who weren't here and who didn't do the quiz, you just tell me if you want me to go through it, right? So I'll just do a rundown of how exactly you would solve this. So they ask you to solve this exponential equation, this right here. What you would do, put each side to the same base. So if you want me to actually write it out, let me know, right? So to solve exponential equations, we know we write both sides to the same base, and then we could equate the indices. That's what you would do here. If you want me to actually do the question with you, write it out on the board, let me know. So that's what you would do for that question. For this question, this is also an exponential equation. However, you see 3 and 7, you just cannot write them to the same base. So what happens when you can't write both sides to the same base? That's when we take logs. We know that. So we'll put logs on both sides and solve the value of x. If you want me to write it out, let me know. For this one, same thing. 1.2, 2.1, can't write them to the same base. I would take logs. Solve x. This is a exponential equation. Looking at this would give me a simultaneous equation and, you know, all of that. So that's when you let something be represented by y and you solve for the values of y, you know, we did that. But if you want me to do it, please let me know. I would do it for you if you want me to write out the question and put it. This is the one we just did. Self X. It's the same process like we were doing here, right? You use the log laws to simplify this, get it in a form, get it in the log form so you can write it in exponential form. Or if you have the form log of m, n to the base a is equal to log of m to the base a, then you could see n is equal to m. So that's what you would do here. The answer for this one was, I think it was 2. Was it 2? Yes, it was 2. Okay. Anybody wants me to do any of these questions on the board now? Any of them?
I am good, guys.
Okay, what about the others? Okay. All right. Well, that was your quiz day. All right. Paper 2, number 1, part D. They gave you this exponential equation, 16. Oh my. 16 to the power of x plus 2 is equal to a quarter. They want you to solve this, solve the value of x. And this was just a 2-mark question because it's relatively simple. What do you do when solving exponential equations? You try to get both sides of the equation to the same base. Remember, not all the time that's possible, but for this particular example, it's possible. So 16 is the same as 4 squared. So I can rewrite this as 4 squared to the power of x plus 2. And then I know that a quarter is the same as saying 4 to the power of minus 1. There's a rule that says, let me write down the rule.
Wait, you are on the board? I can't see.
Oh my bad. Sorry. Right. So this is what I was saying, right? 16 to the power of x plus 2 can be rewritten as 4 squared to the power of x plus 2, because 16 is 4 squared. And then I said a quarter is the same as 4 to the minus 1. What I was explaining just now is that we know a rule that says a to the power of n, and this whole thing, the power of m, is the same as saying, so let me just put the power down here, a to the power of n m. So in other words, if I see something like this, the indices multiply by each other, right? So if I have 4 squared raised to the power of x plus 2, according to my rule, this can be written as, if I multiply these indices, I'll get 4 to the power of 2x plus 4. And this is equal to 4 to the minus 1. Now that I have the same base, I can drop the bases and equate their powers. So what I end up with is 2x plus 4 is equal to minus 1. Now, using simple algebra and transposing to make x the subject of the formula, I can find the value of x. So looking up here, that would be my answer. Everybody good? Yes, no?
Yes.
Well, that's it. Did all the past paper questions. Logs, indices, exponentials, polynomials. Any questions about